This video is to demystify the chemical equation. So chemical equations give us various ways that we need to display a chemical reaction. So you might find that your chemical equation that you are asked to do a word equation, you might be asked to do a balanced symbol equation, or you might be asked, if you're doing GCSE chemistry, to do a half equation. Half equations only appear on the higher tier paper. Let's start off with looking at word equations. So these should be written in words with no chemical symbols. So if we look at the reaction between magnesium and hydrochloric acid, we can see that our reactants are magnesium and hydrochloric acid. Now these are what goes into the chemical equation. So these are both our reactants. The products that come out are something that you are expected to be able to work out if you're looking at Key Stage 3, GCSE or above. You need to be able to work out the products for a word equation. So when we're looking at the word equation, this is making a salt and making hydrogen. In this case, the salt that we're making is magnesium chloride. And we'll also make hydrogen gas. These are our products. So our products are what comes out at the end of a chemical equation. Now, in this case, I get the name of the salt. So our salt is this one here. So our salt is a product of neutralizing an acid. So my salt, I get the name of the metal, and I get the name of the acid. Now in this case, hydrochloric acid, it's the chloric that makes chloride. Okay, so the next type of chemical equation we're looking at is a symbol equation. So I've just kept the word equation at the top, and we'll keep using this chemical reaction throughout. So when we're looking at the symbols, we're looking at the symbols that we see on the periodic table. So we might be looking at an individual atom. In the case of magnesium, we just look at the chemical symbol, being really careful to keep the capitalization and the lowercase letters the same as they appear on the periodic table. Then when we look at hydrochloric acid, we have a chemical formula. So in this case, hydrochloric acid is made up of one hydrogen atom and one chlorine atom. So the formula is HCl. And then we're going to make magnesium chloride. Now the formula for magnesium chloride, it ends up having two chlorine atoms and one magnesium atom. If you understand how to form ions, and we actually look and see that chlorine is in group 7 and magnesium is in group 2 of the periodic table, we can easily see that magnesium will form a 2+ ion and chlorine will form a 1- ion, and therefore we need two chloride ions to balance out the two positive charges on the magnesium. If you're not comfortable with ions, then you just need to start learning some formulae, or you might find that very often formulae are given to you in the question. When we look at hydrogen, hydrogen is a diatomic molecule. Most of our small gases are, apart from the noble gases, so we should know that hydrogen goes around in twos. Now, these little numbers that we have in our chemical formulae, these cannot be moved, they cannot be changed. So at the moment, that is a symbol equation. In order to balance it, we need to make sure that we have the same number of atoms going in as coming out. So we need to make sure that we've got the same number of atoms on this side of each type as we do on this side of each type. What's really important is that when we're balancing, there are only a few positions that we can write in. We can write here, 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 or here. So in this case, in order to balance this equation, I only need to write here, and I need to write a 2. And that 2 means that I've doubled up everything in my hydrochloric acid molecule. So in this case, I've got now 2 hydrogens and 2 chlorines, and that balances out the other side of the equation. If you need more help with balancing equations, then I do have another video that I can send you for that. Okay, so the last type of chemical equation that you need to know about is the half equation. So when we're looking at half equations, this is higher tier only. Okay, so you will not be expected to construct half equations if you're doing the foundation paper. But when we're looking at a half equation, this tells us what's happening in half of the chemical reaction. So if you're doing separate sciences, you'll find that you need to do half equations when we're looking at chemical cells. Everybody needs to do half equations when we're looking at electrolysis, and we need to be able to do half equations when we're looking at redox reactions as well. And the example that we've got here, this is a redox reaction. So when I'm looking at a half equation, I need to know what's happening to the 2 main species in my equation. So the ones that are being oxidized and the ones that are being reduced. So just a reminder of oil rig. So oxidation is loss of electrons, and reduction is gain of electrons. So if we can remember our oil rig, then that will help us a little bit when we're identifying which species is oxidized and which is reduced. Okay, so in this example, magnesium reacts, it goes from magnesium atoms and it ends up as magnesium ions. It ends up as ions. We know that because it's ended up in an ionic compound. So I can see the ionic compound. So something must have happened here. Now, when we're looking at our magnesium, here we've got 1 atom of magnesium going in and 1 atom of magnesium coming out. So the equation is technically balanced, but the charges up at the top here, these are not balanced. So we need to make sure that we're balancing this equation. Now, in this case, because we're only showing part of the equation, we can't add any other atoms in. But what we are looking at, we're looking at electrons when we're looking at half equations. So we're looking at the way that electrons have moved in between atoms. So in this case, I can show electrons, and I know that my magnesium atom, because it's become a positive ion, it has split and it has lost some electrons. So we can show those electrons separately, and we show an electron with a lowercase e and a little minus sign. Now at the moment, we can clearly see that this is not balanced. We've got 1 minus on the electron and 2 plus on the magnesium. But if I add a 2 in front, then we can easily see that we've managed to balance our equation. We've now got 2 minuses and 2 positives. So this is a half equation here. So this is a half equation. The other half equation that we're looking at here, we're looking at what happens to hydrogen, because we can see that hydrogen has also ended up going from an ion in an ionic compound to becoming a molecule. So what we need to have a look at is become a molecule in a covalent compound. So we need to have a look at what's happening with this half equation. So in this case, I've got my hydrogen ions and they're becoming a hydrogen molecule. Now, because I've not got this quite balanced, I've got 1 hydrogen ion going in and 2 hydrogen atoms coming out, I need to first of all make sure this equation is balanced. So now I've got 2 hydrogen ions going in, 2 hydrogen atoms coming out. Now, because I've got 2 positives on my left-hand side of the equation, I need to make sure that I've balanced that out and that I've got the correct number of negatives to make sure that I've got neutral charge overall, because on the other side of the equation, here, my hydrogen does not have any charges. So again, I'm going to use my electrons, and I'm going to put 2 electrons in. So here we can see that I've got my oxidation reaction with the magnesium. So here I've got oxidation, and here I've got reduction. So I've got a redox reaction. Now, redox just means that I've got both oxidation and reduction happening in this equation. You might be wondering what happened to my chlorine ion, but since it was a chloride ion, the chloride has cancelled itself out. So what I've got here, my chloride is an ion there, and it's an ion there. So we don't need to include it. In this case, we call this a spectator ion. So this is the same type of reaction, whether we're looking at what's happening at the 2 different electrodes in electrolysis, or whether we're looking at a redox reaction. But when you're asked to write a word, a balanced symbol, or a half equation, then you need to remember what type of equation they're looking for.